Happy day to you, or maybe not so happy depending on how your day is going. I hope it gets better regardless. All right, today we're going to do a lab that kind of looks at different sounds and making different pitches. So, what you're going to do is you are going to watch a couple of videos that will help you get an idea about how vibrations and pitch work. So then you're going to do a vibrations and pitch lab or activity. You need a ruler and a timer for this. This actually needs to be done with two people. It's really hard to actually do it and time it. And if you try and count in just in your head while you're doing it, it just won't be accurate. So I would suggest if you don't have someone to work with, then you need to make sure that you just watch the video of me do it and take my data. I want you to try it, but then watch the video of me doing it so that you can actually get the data. But I definitely want you to grab a ruler. I definitely want you to practice with the vibrations that the ruler makes on a table or a countertop. I'm sure most of you can handle that. So let's look at the background information together. Pitch is related to frequency. Remember, frequency is how many waves go past a given point, right? Changing the number of vibrations per second changes the pitch. So that means that changing the frequency also changes the pitch, right? You speed it up, you get a different pitch. You slow it down, you get a different pitch. The pitch a tuning fork generates depends on the length of its prongs. Shorter prongs produce higher pitch, frequency sounds than longer prongs. Long prongs will bend more readily and therefore tend to vibrate at a lower frequency when struck. When sound waves move through the air, each air molecule vibrates back and forth, hitting the air molecule next to it, which then also vibrates back and forth. The individual air molecules do not travel with the wave. They just vibrate back and forth. When the vibrations are fast, high frequency, you hear a high note. When vibrations are slower, you hear a lower note. A lot of you tend to not read this piece of a lab. Please make sure that you always read the background of a lab. And then when you get to your lab questions at the end to analyze, you'll need to go back and refer to this information if you're unsure of your answers, okay? It does have the answers right here. All right, the key questions. So these are the things that you want to ask yourself while you're doing your lab. What happens to the number of vibrations when pitch goes up? What happens to the number of vibrations when pitch goes down? How can the pitch of an instrument be changed? So here's your activity. You're going to hold a ruler tightly to a table and hit the other end. Then you're going to observe how the number of vibrations and sound changes when the ruler is extended to different lengths off the table. Here's where you want to watch the video. So watch the video of it being done. Your measurements are going to be different. I put your measurements here because you're going to use centimeters. You're going to use 27, 15, and 3 centimeters off the lab table, okay? Or the countertop or the table that you're using if you're doing it at home. So when you put your graph together, you probably will not get more than 6 seconds, but you should go up in equal increments. Maybe you have to go up to 8, I don't know. Depends on the length of what you're using. And if you don't have a ruler, you can use a stick or a wooden spoon, anything that kind of bends and is flexible a little bit, okay? But also has a little bit of elasticity that you can actually see or hear. All right, so if you have a 27 centimeter ruler off of the table, you're going to have a bigger wave, okay? A longer wavelength. If you have it 3 centimeters off, you're going to have a short wave because you just have a short little amount off the table. When you're done and you've plotted this graph, and just make a line graph, it should go in this direction. Okay, that's where your lines should go, in that direction. Just plot your 3 points wherever they might be and just make sure that you understand that you need your longer wavelength here, shorter wavelength here, okay? When you're done, you're going to want to upload a picture of your graph. So take a screenshot of it, or you can print this off, or you can make a copy of it, or you can copy it from a Google Doc and maybe drag it onto your computer screen, whatever you're comfortable with. I would suggest just take a screenshot, drag it to your desktop, and then when you do the quiz and the analysis questions on the form and upload it, it's just really easy to upload it from your desktop. Okay? These are the questions that will be asked of you. What happens to the number of vibrations when the pitch goes up? What happens to the number of vibration when the pitch goes down? And how can the pitch of an instrument be changed? I will also ask you to look at two waves. One wave will be like this. And one wave will be like this. And I will ask you which one of those waves is a higher frequency and which one is a lower frequency, or which one is a higher pitch and which one is a lower pitch. Feel free to use your notebook. Again, you can look back at pages where we already have this information so that you make sure that you get your answers correct. You only get one try. It's an assignment. So good luck. Make sure you submit your assignment properly. When you're done with it, I will ask you to watch another video about pitch and start thinking about making an instrument of your own at home. All right, have a good one. Play with the rulers and watch for those vibrations. Good vibrations.